So today, you're going to hit me a little bit because I've been holding out on you. All of the mechanics, the mathy part, our calculators do that for us. It is important to know what's going on under the hood, so to speak, which is why I haven't mentioned calculators yet. But today we're going at a higher level, so it will be easier if we can just ignore all of the calculations and focus on why we are computing something rather than just how to compute it. All right, today we're going to take a look at telling the difference between everything we've been doing. Confidence interval and the hypothesis test, and the difference between 1 and 2 proportion samples. So we'll start with confidence intervals and hypothesis tests. We've seen a good bit of this before. A hypothesis test is asking, is there a difference? Whereas a confidence interval is asking about what is the difference or what is the value. There's a lot more here, obviously, but just those two questions are all we really need to look at today. For 1 proportion and 2 proportion, we haven't seen this so much. 2 proportion has been confined to the last chapter, but the names should be a pretty big giveaway. The 1 proportion sample, it only comes from 1 sample, whereas 2 proportions, it comes from 2 samples. So with 1 proportion, we might be asked to compare it to either a certain value or something that we could easily calculate, like asking if a coin is fair or not, because the default rate would be 50%. Whereas 2 proportions, we will have 2 different samples. They could be from different points in time, like 2010 and 2020, or they could be one from men and one from women, or maybe we have a sample from Wisconsin and a sample from Minnesota. So let's take a look at a couple of examples here. Take a second and read that. So there are 2 questions we're asking ourselves, right? We're looking to see if it's 1 sample or 2 samples, and we're looking to see if we are a hypothesis test or a confidence interval. So we only have 1 sample here, right? The 42% of the 1,546 African American women. So we are 1 sample. And it's asking in what range can we be confident the true proportion is. So we're not asked to compare this to a different value. We're just asked what might the true value be. That means this will be a 1 proportion confidence interval. Take a second and read this new example. All right, so the same 2 questions. Is it 1 sample or 2 samples? And then is it a confidence interval or a hypothesis test? So what we're doing here is we're trying to compare the rate of eclampsia between patients in the magnesium sulfate group and patients in the placebo group. So there are 2 different samples. Essentially, each of these should be an independent sample from each other of approximately 5,000 people. So this is a 2 sample where we will be comparing the proportions. And furthermore, it is a hypothesis test because we want to see if there is a difference. We're not asked how large is the difference, we're asked, is there a difference? So this is a 2 proportion hypothesis test. Here we have a list of summarizing everything that we have done so far, all of the 4 different possibilities, along with the location on the calculator. Everything is under the stat and then over to tests, and then each of the different things, either a 1 prop z test, a 2 prop z test, a 1 prop z interval, or a 2 prop z interval. And I'll show you where that is right now. All right, so I've written down the relevant portions, the numbers of those problems, and I'll show you where everything is on the calculator under stat right here. tests. We're looking for a 1 proportion Z interval. It is letter A. X is the number of quote-unquote successes. We're not given that here. We can do some math in here, but we will have to round. It'll throw an error if we leave a decimal, so we'll round that to 649. And then out of 1,546, find a 95% confidence interval, and that's what we're doing. So the whole thing looks like this. We've got model. All right, these are the same things we've been doing. Independence. We're looking for a random sample. And we're looking for less than 10% of the population. We obviously don't see that here, but in the original problem that I didn't even put in the PowerPoint, we are good on both of those. And then we are looking for sample size. So we need NP to be greater than 10, which is 0.42 times 1,546, and NQ, which is 0.58 times 1,546 to be greater than 10. The mechanics section was the annoying part before. Now we've already done it. We need to say what we're doing. We are doing a 1 proportion Z interval. And list the relevant portions from here. So our p hat, essentially, n is already there. Actually, p hat's already there too. So we don't really need to write either of those down. If this was a number, we should write p hat down, so we'll do that anyways. And then our interval is between 39.5% and 44.5%. So our conclusion, we are 95% confident that between 39.5 and 44.25% of African American women have a vitamin D deficiency. Our second example involving magnesium sulfate and eclampsia. We have the data here. That was a 2 proportion hypothesis test. So again, under stat and tests, we are looking for a 2 proportion test, 2 proportion z-test, number 6. All right, we have a couple different things to look at here. The 2 different proportions, and then which way our hypotheses went. So let's take a second and write down our hypotheses. So our null hypothesis is going to be the proportion of people on magnesium sulfate that got eclampsia is the same as the proportion of people on the placebo. our alternative hypothesis is going to be that the proportion of people on magnesium sulfate who got eclampsia is less than the proportion of people on placebo who got it. So looking back at the calculator, we want, so P1 was magnesium sulfate, 40 out of 4,999, and P2 is the placebo, so we want P1 is less than P2. This is always the step where it's you want to write down your hypotheses beforehand. It's a little easy to get turned around and mistake something for something else. We'll do the model real quick. Same stuff, we need independent samples. So that's the newish one. We don't have the original text of the research article, but we can hope they did a good job. For independence, we need random and less than 10% of the population. Again, there's not enough here to say that, but if it was published in Lancet, it's probably relatively well done. And then our sample sizes. 40 is greater than 10. 4,959 is greater than 10. 96 is greater than 10. And 4,897 is greater than 10. All right, now for the mechanics. We just calculate. We get a whole bunch of stuff. So what do we need? We kind of want those two p hats, and let's be specific in what they are. P hat of magnesium sulfate is 0.008. P hat of placebo is 0.0192. We had the sample sizes listed already, so we don't need to write those down again. And then we get our z-score and our p-value. It occurs to me that we forgot to write down what we're doing. We're doing a two-proportion z-test. So the AP requires you to either list the test that you're doing if you use a calculator, or show your work in calculating the value. We haven't really bothered with this up until now because we have been showing our work. Now we're cheating. Well, not really, but taking a shortcut. So we'll tell everyone what we did. All right, our z-score is negative 4.84. That's a small z-score. Our p-value is 6.4. That's not right. E negative 7 times 10 to the negative 7th. So our p-value is 0.00000064, which is very small. That leads us with our conclusion. So with a p-value of 0.00000064 is less than 0.05, we reject the null hypothesis. There is strong evidence that magnesium sulfate prevents eclampsia. I'm saying prevents because I'm assuming it was a experiment and not just an observational study.